Hello everyone, this is my final video for studies in network-aided learning system, and my title is Titans QFWP, a regime-aware hybrid quantum fastway architecture for portfolio optimization. And I'm Min Kai Hong. Let's start off with our motivation. Financial markets are highly non-stationary, making stable portfolio learning challenging. Traditional portfolio optimization methods rely on fixed correlations and struggle under distribution shifts. Deep reinforcement learning enables direct sequential portfolio optimization without explicit price prediction. Value-based RL methods suffer from the Bellman curse of dimensionality, leading to unstable policies in complex financial environments. Although A3C improves training stability through asynchronous updates, it may still generate excessive turnover in noisy markets. Static clustering methods fail to capture dynamic regime transitions in evolving financial markets. Variational quantum circuits provide expressive nonlinear representations for financial time series modeling. However, existing PQC-based trading frameworks often rely on static parameterization and limited state representations. To address these limitations, we propose Titan's QFWP, a hybrid framework integrating asynchronous RL, regime-aware representations, dynamic memory mechanisms, and continuous reward optimization for adaptive portfolio management. And for the method, we have the S&P 500 market data, and we did several feature extraction, and we did dynamic regime clustering for through K-means Hungarian algorithm and EMA. And we have the 53 dimensions regime state, and we did the persistent memory fusion, and we have the Titans QFWP, and then we have the portfolio location of 10 clusters, plus you can hold on to your cash as a choice. And we have the continuous reward optimization. And as the part of the after the persistent memory fusion, we have the 8 dimensions memory augmented state, and it went through dynamic gate generator to have the 48 quantum rotation parameters, and then we have 8 qubit variational quantum circuits to form the policy head and value head afterward, and we have the portfolio weights. And these are the some formulas in the model of Titan's QFWP. So initially we have the historical templates. We have the 4 learnable tokens, and plus the current proxy, and we'll uh, this formation will feed into the classical encoding. So for feature encoding, so uh, it will rotate uh, through the axis of y and went through the Hadamard gate, and then for the 48 dynamic rotation, we will rotate through x axis, y axis, and z axis. So, and the entanglement we apply is the local entanglement. And let's talk about the adaptive fastway memory module. So, for persistent memory, it stores historical patterns, and the function is long-term regime memory. As for the surprise method, the momentum, uh, it's smooth dynamic updates which adapt to momentum learning. If the forgetting gate remove outdated information, and which the function is regime transition adaptation. And let's talk about the formulas for the three of them. So for the persistent memory, as we mentioned before, it it has the learnable tokens into the initial feature. And for the surprise momentum, it will deduct the features and to form the next momentum. And as for the forgetting gate, you also use the parameters of alpha to make some of the uh, unnecessary noisy noisy features out of the uh, the state. And for our transaction cost aware continuous aware, so as you can see, we use the fixed point transaction cost. So you can see from the formula. So the C means the 15 basis point trading cost, and it will also went through the from 1 to 11. So because we have the 10 clusters plus the uh, holding on to the cash action. And as for the continuous reward, so because we did our transaction every 20 trading days, so the the formula you can see the edge is 20. And why we times 100? Because as we chaining uh, we want the training to be stabilized. So uh, it's better for the Titan's QFWP for updating. And let's talk about the data overview. So we have the daily log logarithmic returns of S&P 500 consti constituents, and the time span is January 2015 till April 2026. So the final stock universe is 468 uh, stocks. And the assets, we have the missing observation were excluded. And the bias control is that all clustering and state construction use only information available up to time step t, which is 20. And we prevent look ahead bias during training and evaluation. And the data split, this is the period of training, validation, and testing period. And you can see from the period and also our trading days. And we did the equal parameter count evaluation. So our target is around 3,000 parameters, which the same training budget, and compare structural uh, dif differences. And the evaluation setup is the 13 architectures evaluated and 10 random seeds from 1 to 10, and same optimization protocol across all models. And you can see our experimental configuration summary. So the decision interval is every 20 days of trading days. And also you can see our redundancy and also the framework we use. And the evaluation metrics we use is the annualized rate of return, annualized volatility, and maximum drop down, Sharpe ratio, karma ratio, information ratio. And this is our experimental results. So you can see from the bold text, which is the Tidance QFWP full. So as you can see from the quantum architectures, uh, ex- except from the volatility part that is worse than other baseline and all those ablation models, but the annual return and max drop down and all other Sharpe ratio uh, metrics, you can see it outperforms the baseline and also other ablation. And you can see uh, it has the similar results through through the the FWP ablation. So so this is uh, the results of table one. And so for the ablation findings is that the persistent memory is most critical stability component, and the surprise momentum is for the parameter smoothing, and the forgetting gate is the regime adaptation. And let's see another result. So we target into our Tidance QFWP that this is the top 20 selected assets through the testing periods. So as you can see that uh, so for explaining this picture, the the gray part that didn't have any numbers on it is meaning that the agent did not select these stocks through that period of time. And the the one with colors and also numbers is represent uh, the return through through that period. And as for you can see from the left, you can see how many times the agent picked that kind of stocks and how the win ratio. Okay, so let's talk about it deeply. So for the main observation is that portfolio allocations dynamically rotate across sectors, and technology related assets dominate bullish periods. But it also have the defensive adaptation during major market drawdowns. So it also reallocates toward lower frequency defensive assets. And the final is our conclusion. So Tidance QFWP demonstrated lower downside risk characteristics and improved drawdown resilience, more stable regime aware behavior, and better adaptive allocation dynamics. So the final takeaway is control evaluation protocols are essential when comparing hybrid classical quantum reinforcement learning in systems. And the study highlights observable behavioral defense different differences under identical parameter budgets rather than claiming universal uh, superiority. So this is my uh, final presentation. Thank you for your time.